An orangutan climbed up a building. A little puppy fought God. A chicken clucked loudly. Are these sentences about a dog? There's only one way to find out. A neural network. But how do we actually make a neural network? Neural network recipe. Step 1. Get data. Step 2. Get tokenizer. Step 3. Make model. Step 4. Train model. Step 5. Test model. And step 6. Predict dog. For the data step, I'm going to be using a local LLM to generate synthetic data to train my model on. Synthetic data is data generated by a neural network, and in this instance, we're going to be using an LLM to generate text data to train the network on based on dog texts or not dog texts. All right, now let me just boot the LLM right into my GPU and shit. Oh, fuck. All right, guys, I think I'm gonna have to use an API instead. Oh, fuck. Okay, so I found this API Grok. Oh, not that Grok. It's this Grok with a Q. It's just a free API thing online. Honestly, kind of useful if any of you need a free API. But here we go. In the meantime, I'll tell you how I generated all these different prompts with my very high level prompt engineering that I've come up with. Basically, I just asked an AI how to prompt engineer, but that's the first step to prompt engineering. You got to prompt. So the best way to prompt basically with LLMs is they will generate the same thing over and over again, or nearly the same thing over and over again if you keep on asking for the same prompt. So you gotta basically like get a bunch of, you gotta inject difference within like what you're asking for whenever you're asking for all of the synthetic data to be generated. So as you can see, I inject scenarios for the dog or the not dog scenarios, and then based on that we'll get wildly different results to add more like sparsity and difference to the data set. Skipping to the end, now that we have the data, we can create a tokenizer that we'll use to then train the model based on the text and the data set that we just generated. For this project, I'm simply using a very, very simple tokenizer that comes from the library sklearn called count vectorizer, and it basically just counts how many of each word there is in the sentence that you give it. Then it counts positionally, like where, how many of each word there is, and then it puts it into a vector that you then can feed to the model. And then the model will then learn, oh, okay, if it's in vector, like say like place 2, that corresponds with the word house, and house usually corresponds with a dog or something like that. Now to actually make the model, you got to use the good old Python library PyTorch. That's what everyone uses. They use PyTorch, they make a class, and then they connect the neural network layers one to the next to the next. That's what everyone does, and that's what I did here too. As you can see, the vocabulary size is how big of an input that you're passing in to the neural network when you pass in the input, and then there's 20 hidden layers in between, so it sends out 20 from the vocabulary size, and then 20 goes in, and then it computes, and then it just has one output, either true or false. It's either about a dog or not about a dog. To train the model, the middle 20 weights we were talking about earlier are initialized to random numbers. These 20 weights are called hidden weights, and in many neural networks there's way more than just 20, and there's way more layers than just one layer of 20. But for this one, 20 is more than enough to solve the problem, the dog problem or the not dog problem. To then train the 20 weights that we have inside the dog or not dog neural network, we use a process called backpropagation. So we send through the data, we tokenize the data, we send it through, and then we backpropagate, which we calculate the error, and then we slightly change the weights to better get the right value next time. And then we do that for all of the data in the data set, and then we do it for all of the data in the data set over many generations, which are called epochs. And then after enough epochs, the hope is that inside of the 20 weights, enough of the stuff is generalized and enough of like the information that contains dog or not dog is within the weights, so that when you give it random like examples or things that weren't originally in the data set, it'll be able to predict whether it is about a dog or not about a dog. Next, we move on to testing the model to validate that it has generalized what it needs to know to do this. At the very beginning, I cut the data set in half so that we would train on half the data, but the other half of the data would be used as a test to see if the neural network learned all the correct patterns and it'll be able to predict new labels based off of new data. As you can see here, running through the test data set, it gets a 99.8% accuracy. So it has learned very well what makes a sentence about a dog or not about a dog. Now let's go back to the beginning. An orangutan climbed up a building. A little puppy fought God. A chicken clucked loudly. As you can see here, the classifier works perfectly. If y'all want to check out the code, it is in the description below. Make sure to go like and subscribe. You will not want to miss the next video. We're going to be making a robot arm move with reinforcement learning. Seriously, that shit coming out in like a week or 2 or maybe even 3, but probably not 4. See ya next time.